In this lesson, we'll be adding and subtracting rational expressions. And since we'll be dealing with rational expressions, I want to remind you that our first step should always be to factor. Factor in anything and everything you can. The next step is to find the LCD. Now, a reminder, we're not talking about the liquid crystal display. We're talking about your least common denominator. Now, once you find a least common denominator for fractions or rational expressions, same thing, all you have to do is add or subtract your numerators. So let's look at a few examples. Example 1. Okay, in this example, we already have everything factored, so we don't have to do that step. Now we need to find the least common denominator. The way you find a least common denominator in fractions is to multiply to make them the same. So these are not the same, but remember, one of the shortcuts is that you can multiply them together, and that would give you a common denominator. So I'm going to multiply this one by x minus 3, but I also have to multiply the numerator, so that we're multiplying by 1. And then I'll multiply this one by x plus 1 and x plus 1. So now I've got 3x minus 9 over x plus 1 times x minus 3 plus 2x plus 2, because I went ahead and distributed, over, and I can write it as x plus 1 and x minus 3. It doesn't matter what order. Now remember, when you have fractions, the denominator is going to stay the same. At the end, we're just going to add the numerators. So 3x plus 2x gives me 5x, and then negative 7 plus 2, negative 9 plus 2 gives me a negative 7. My mind was working faster than my pen. All right, next example. And let's have one where we actually do have to factor first. Got x over 3x minus 6 plus x minus 1 over x squared minus 4. So I want to factor anything and everything I can. This numerator I can't do much with. That's just an x. But I can factor out a 3 out of the denominator. So I have 3 times x minus 2. Now on the other one, I already have an x minus 1 there. Can't factor anything out of it. In the denominator, I can factor x squared minus 4. That's x minus 2, x plus 2. All right, so we compare. This one has an x minus 2, and so does this one. But this one also has the x plus 2. So I need that on the first one. If I multiply the denominator by it, I also have to multiply the numerator. And on the other one, it needs a 3. So I'll multiply the numerator and denominator by 3. Now, I'm going to go ahead and distribute. X times x gives me x squared plus 2x. And you know what? Since I'm going to be adding them and putting them all in the numerator anyway, I'll just go ahead and distribute here. That'd be plus 3x minus 3 all over that common denominator, which simplifies a little bit more, x squared plus 5x minus 3. Now I want to double check to see if that numerator factors, and then I could simplify it anymore. Oops, yeah, that was a minus 3. So I think about it. No, I can't think of anything that multiplies together to give me 3 that would add to give me 5. So we're done. Let's go on to the next example. Example 3. x plus 1 over x squared plus 5x plus 6 minus, so let's do a subtraction problem, 2 over x squared minus 4. So now I want to factor anything and everything I can. This numerator doesn't factor. The denominator, oh, that's an easy one. That's x plus 3 and x plus 2. And I'm going to give myself a little space here. And this is easy too. This is x plus 2 and x minus 2. So now they both have an x plus 2, but I look for what they need. This one needs an x minus 2. And this one's going to need an x plus 3 to make a match. Now let's see. This is going to give me x times x is going to give me x squared. Negative 2x plus x is going to give me a negative x. Then 1 times negative 2 is going to give me a negative 2. And then I'm going to subtract this. So let me go ahead and distribute. This would be 2x plus 6. Now we have to be careful when we have subtraction, because we're subtracting each of those things. So we're going to be subtracting a 2x and subtracting a 6. In the denominator we have x plus 3, x plus 2, and x minus 2. Now I'm going to simplify if I can. I only have an x squared. I have a negative 3x and a negative 8. And we'd like to factor if we can. So what would multiply to give me negative 8 and add to be negative 3? Nothing. So you're done. Let's do one more there that could be kind of challenging. It looks scary at first, but it's actually an easy one. 6 over x minus 4 plus 1 over 4 minus x. We want a common denominator. Remember, there's this neat little trick that if I take 4 minus x and multiply it by negative 1, remember what happens. If I multiply that by a negative 1, that'll give me a negative 4 plus x, which is actually x minus 4. So there's that little trick that'll reverse a binomial. If I multiply the top by negative 1 and the bottom by negative 1, I'm going to reverse that binomial. The first one's still 6 over x minus 4, but now this one is negative 1 over x minus 4. And now we have common denominator, so we can just add our fractions. Now, something else we encounter in this unit is what is called a complex fraction. Now, a complex fraction is a fraction within another fraction. So let's mark that. That's a fraction within a fraction. We do not like fractions within a fraction. We don't like decimals within a fraction. So all of those are big no-nos. So here's the trick to getting them out of there. So let's look at one. I've got 2 over x minus 4 over 2 over x plus 3. All right, so we want to get rid of the fractions within a fraction. Well, I know if I multiply 2 over x by x, the x's would cancel and I'd be left with 2. So let's try it. Let's multiply the numerator by x. Now, remember, if I do that to the numerator, I better do it to the denominator because it's really multiplying by a version of 1. Now watch what happens when I distribute that. X times 2 over x is just going to give me a 2 minus 4 times x, which is 4x, over x times 2 over x would just give me a 2 plus x times 3, which is 3x. Now I like to rewrite it a little bit. I like to put the x's first. It doesn't really matter. But that's all you have to do. Now we do not have a fraction within another fraction. Let's look at one that's a little bit more complicated. Okay, so this one, we have two different denominators within our fractions. So let's just handle it piece by piece. Let's start with the x. That one was easy last time, so let's do the x. We're going to multiply the numerator and the denominator by x. Let's see what happens. X times 6, so that'll be 6x over x minus 5. Plus x times 1 over x, which is just going to give me a 1. In the denominator, x times 3 over x is just going to give me a 3. Minus, it's going to give me a 2x over x minus 5. Now, let's get rid of the x minus 5. So I'm going to multiply the numerator by x minus 5 and the denominator by x minus 5, and let's see what happens. When I multiply this fraction by x minus 5 and x minus 5 are going to divide out, and so I'm going to be left with 6x plus x minus 5 times 1, which is going to give me x minus 5. In the denominator, I have x minus 5 times 3 minus, now the x minus 5s are going to divide out, and I'll just be left with 2x. Now, I'd really like to simplify this up a little bit. That's really 3x minus 15, right? Okay, combine my terms. 6x plus x is 7x minus 5. We have 3x minus 2x, that's an x, and then minus 15. Complex fraction, gone.